This week we're going to talk about whether or not functions are even or odd. Important to note that most functions are neither of them. The reason that we use this is to help in the purpose of graphing. If we know that something is even or odd, then makes it quicker and easier to graph. We are only going to be looking at the graphs of them, but a function is even if there is reflexive symmetry about the y-axis. So it would have to be symmetric, the graph, about the y-axis. Okay, so in other words, like when you would graph a quadratic equation, for example, all of the y values would be similar in nature for the x value. So example, if I plugged in -2 and got 4, when I plug in 2, I would also get 4. And if I plugged in something like 4 and I got -4 and I got, let's say, 16, when I plugged in +4, I also got 16. So the graph would be somewhat, in this case, we'd be talking about a quadratic equation, and there would be symmetry across that y-axis. In other words, I could fold my graph over that y-axis and they would match up. Now, when we're talking about this, we can have that function then, a quadratic, let's say, move up or down like that, okay, and that's still symmetric, or this one is symmetric, okay, but it is not symmetric about the y-axis if the function moves left or right at all. So if I moved over here, I am not symmetric about the y-axis. I'm actually symmetric about this vertex right here, this point, whatever that vertex is. So this would not be even, it would be neither. Okay, so it would only work if the function is symmetric about the y-axis. Now there's other things other than just a quadratic, but linear and exponential functions will never be even. If you think about it, if I look at an exponential graph, if I fold over this y-axis, the points do not line up. Therefore, that would not be true. Okay, so the only ones that we're going to look at really are quadratics, but another one that we have talked about would be absolute value equations. It would also be symmetric about the y-axis, or even functions. So again, in order to be even, you would have to be able to fold it over the y-axis and the points would have to match up. Okay, in order to be odd, it has to be symmetric about the origin. Okay, or rotated, let's write rotated about origin 180 degrees. Okay, so an example of that means, if I have something at 0, 0, okay, and then I have something at -1, -1. What we're saying is that when we plug in the opposite, we get the opposite. So if I plug in -2 and I get -2, when I plug in +2, I get 2. This linear function right here is symmetric about the origin, because if I rotate, let's say, this bottom half 180 degrees, it would then be lying on top of that. Okay, so functions that are odd, again, would have to be able to be rotated around that origin, which is at 0, 0, and they would have to match up. So many linear functions work, okay? Now, it has to, in order to be odd, it would have to, that center, that symmetry has to be about the origin. So a linear function that moves up, this is not symmetric, or not rotated about the origin. This is not odd, okay? Now that line of symmetry could go the other direction, okay? So for instance, like this, okay? But we cannot move left, right, or up, down. So essentially it has to go through that origin, and when you rotate it, it has to be able to lie on top of it. This is odd because it's symmetric. This is odd, okay? This would be neither. Okay, so when you're looking at the graph, you're basically asking yourself two questions. Even, it has to be symmetric about the y-axis. So look at the y-axis, fold it over. If it is, you're good. it's even. If it's rotated about the origin, which would not be any exponential or quadratics at all, would have to be linear, then in this case, then you'd have to be able to rotate it around the origin on top of the other one. Okay. And the other thing that we need to kind of just recap is whether or not functions are linear, quadratic, or exponential. So remember, linear equations, the graph of a linear equation, like we've kind of already talked about, is that it has a slope or a rate of change that is constant. So it has to create some type of line, right? This is a linear equation. There can't be any curvature, it can't jump up quicker of any certain type, but that's a linear. The quadratic must be U-shaped in some sort, and there must be symmetry. In other words, there has to be a vertex and there has to be symmetry. So some type of U-shape would make this that's a quadratic equation. That x increases at some, or as x increases, y increases at some point and decreases at some point. And an exponential equation, remember, we get exponentially large or exponentially small. So for example, here's an exponential equation where it jumps up really big like that. Another example would look something like this. Okay, there's many of options, but remember, exponential equations get very large very quick or very small very quick. So all we're going to do down here is just describe whether this is even, odd, or neither, and tell if it's a linear, quadratic, or exponential. So really quick, I'm just going to go through. This is a quadratic. This is exponential. This is linear. This is a quadratic. This is exponential, quadratic, linear, quadratic. Okay? And if we're going to look to compare to see if things are even, odd, or neither, remember, we have to check two things. One, is it reflected about the origin? And two, is it reflected about the y-axis? Here's this y-axis. If I fold that graph over, it is not on top of it, so there's no symmetry about the y-axis. It is also not symmetric about the origin. If I rotate it 180 degrees, it is not on top of each other. This is exponential. If I reflect this over the y-axis, this would look something like that, which is not on top of that. So this is neither as well. It is also, if I rotate it about the origin, it is not on top of each other. Linear functions can only be odd, and if I rotate this about this point, it is not odd because it is moved down, so this is also neither. This function here is the y-axis. If I reflect that over the y-axis, those points are not on top of each other again, so this is also neither. Most exponential equations, or all exponential equations I should say, are neither. If you move that, rotate that about the origin, it's not on top of each other, and if it's reflective about the y, that's not work. This quadratic, it is reflective over that y-axis. When I fold it over, it is. So this one, because it is even. This linear function is going to be odd because as I rotate that bottom part of that line would be on top of there. So that is. And this quadratic here, is it symmetric about here? And it sure is, so it's even. So again, most functions are neither. But every once in a while, any quadratic that is on the y-axis, has a vertex on the y-axis, will be even. Any linear function that has a runs through the point 0, 0, or the origin will be odd. Plot the points on the graph and determine whether the graph represents a linear, exponential, or quadratic function. So if we look here, I went ahead and plotted these 8, 4, 4, 0, and so forth. And as you can see, that appears to make a straight line, so we're going to go ahead and say this is linear. Here, I accidentally had this point written wrong on your paper, so you might want to change it. I believe it was 3, -6. It should be -3, 6. And as you can see, this makes a U-shaped graph. So this would be quadratic. And in number 11, it appears that it's getting smaller pretty quick. It kind of shows this exponential graph, so this one is exponential.